So exercise 1204 is about variance and standard deviation. So variance is a measure of spread, how spread out our data is. If it's really, really spread out, we're going to have a big number. If it's not so spread out, we'll have a much smaller number. And the symbol for variance is this sigma squared. That's a lowercase sigma. Sigma is actually the symbol for standard deviation. So standard deviation is the square root of variance, or if you square standard deviation, you get variance. So standard deviation sigma, sigma squared is variance. So these statistics consider the difference between each score and the mean. So it's the expected value of that difference, or the kind of like averaging out the differences from the mean. So if they're really close to the mean, you average out those numbers, they'll be quite small. If they're a long way from the mean, you average out those numbers, they'll be much bigger. Now, when we see expected value, just like in the other exercise, it means to add those things up multiplied by the probability. Now, this is from your reference sheet, and you can see that formula right there. We'll look at the second one in a minute. But right there is that formula, but the capital E means add up and multiply by probabilities. And then to find the standard deviation, you just square root that. Now we do use an S for the sample standard deviation and the sigma for the population standard deviation. And these calculations are all finding the population standard deviation, which is what we mostly do here. So if you're using your calculator, you are looking for the population standard deviation. So here's an example. We're going to find the variance and standard deviation of the discrete probability distribution below. So we can see there's a 0.4 chance of 1, a 0.5 chance of 2, and a 0.1 chance of 3. So the first thing we need to do is find the mean. And this is this formula we saw in the previous exercise. So we add up each score multiplied by its probability. So 1 times 0.4, 2 times 0.5, and 3 times 0.1. And that all adds to 1.7. Now to find the variance, we need the expected value of the scores minus the mean squared. So add up the scores minus the mean squared, multiplied by probability. Okay, adding up all those things. So the first score is 1, subtract the mean, square it, multiply by the probability. The second score is 2. Subtract the mean, square it, multiply by the probability. The third score is 3, subtract the mean, square it, multiply by the probability. So that's exactly what this formula is saying, but it's also what this formula is saying as well. The capital E is the same as add up and multiply by the probability. You'll notice on this one I've got a capital X because that's talking about the whole data set, and I've got a lowercase x here for each score. Now that equals 0.41. So we square root that to find the standard deviation, and that's 0.6403. And it's common here that we'll give that to about 4 decimal places. Now, let's look at that other formula that's on the reference sheet. It's actually much, much easier. You do need to know both. You could be asked both. It is important to know both of those. They're both on the reference sheet, so you should know them both. But this one is much easier. So it's the expected value of the squares of the x's minus the mean squared. Okay, so expected value means add up and multiply by the probability. So let's have a go at this much, much easier example. So find the variance and standard deviation of the discrete probability distribution below. So there's a 0.05 chance of 3 occurring, a 0.45 chance of 4, and a 0.5 chance of 5. You notice that is left skewed data or negatively skewed data. If you graph it, it's looking like that. So you'd expect the mean to be further towards the right where the probability is heavier. So let's have a look and see what we get. So step 1, find the mean. So each score multiplied by its probability added together, and that equals 4.45. So now we just find from that formula on the reference sheet the expected value of the squares minus the mean squared. So remember, expected value is the same as adding up multiplied by the probabilities, and this time it's the squares. So that's quite similar to this formula here. The only difference is the squares. So the first term there, instead of being 3 times 0.05, it'll be 3 squared times 0.05. And then adding up the 4 squared times 0.45 and the 5 squared times 0.5, and then subtracting the mean squared. If you put that all in your calculator, that's 0.3475. To find the standard deviation, we square root it, and that's 0.5895 to 4 decimal places. Now, there are instructions for using your calculator to find the variance and standard deviation on page 684 of your textbook. So let's just have a look at how to find the variance using your calculator. So remember mode 3 for stat, and then just press 1. We will use 2 next year, but we're only going to be using 1 and 2 in this course. So right now we're doing 1. Now remember, if your frequency column is not turned on, you can go Shift Setup, then down arrow, 4 for stat, and frequency on, so 1. Okay, so let's enter these scores. So 3, 4, and 5 are our scores. And then remember, arrow across. You can arrow up, but if you just go down 1, it'll take you back to the top. Let's put in 0.05 equals, 0.45 equals, and 0.5 equals. And then we press AC, remembering it's not going to forget our data. Then Shift 1 for stat. Again, we're going into 4, the VAR, variables. Now, see, this one here is your sample standard deviation. We're not going to use that. We're going to use this one, unless we're told otherwise. We're going to use the population standard deviation. So that is 3, and press equals, and you'll see there's that same answer there, rounded to 4 decimal places. If you want the variance, you square that, and that will equal, you square your answer, and there's your 0.3475.